Hello everyone. The topic of the day is number system, class 9th, chapter 1. Let's have a look. What is number and what are the number system from where we started?
We will learn how and why new number systems were added to the existing collection of numbers. Early man started counting with 1, 2, 3, 4 and so on. These are counting numbers or natural numbers. Next, 0 was added to the system of natural numbers. This new system of numbers came to be known as whole numbers.
Now the question arises, what was the need of 0? The need of 0, if I can ask you, say how many lectures you have attended of number system till now of class 9. You will say not even one. So to represent this not even one or to represent the condition of nothing, we required a number. That number is 0.
Subtracting a whole number from another whole number does not always give a whole number. Hence, the need for a new system of numbers was felt. Then, the collection of integers was formed. Integers consist of whole numbers along with negative numbers. Dividing an integer by another integer does not always result in another integer.
So here we require the negative numbers. If we subtract two whole numbers, it may or may not be the whole number. If it is not the whole number, we require integer in that case. If we are dividing two integers, we are not getting an integer. In that case, we required a fraction or a rational number. Fractions are positive, that is the part of whole. So we are not discussing the fraction over here. We'll discuss directly the rational numbers.
The system of rational numbers came into being. Rational numbers include integers, whole numbers, natural numbers, and fractions.
So the set of all the natural numbers, whole numbers, integers and fraction with positive and negative sign is known as rational numbers. So till now, whatever the number we are aware about, that could be natural number, integer, whole number, fractions, or the numbers in the form of fraction but negative sign, p by q. All these numbers are rational numbers. Yes, the integers are also rational. If I can say 1, so I can write 1 upon 1 as p upon q. So that is also a rational number.
Mathematicians realized that there were still some numbers on the number line which did not belong to any of these systems. These numbers came to be known as irrational numbers. The system of rational and irrational numbers is together known as the real number system.
So here we have set of rational numbers which are rationals, that is are in the form of p by q, but there are certain numbers which cannot be able to represent in the form of p by q, that is the root numbers which are not a perfect square, or the numbers which we cannot be able to represent in the form of p by q. They are considered as irrational number. The set of rational and irrational together is known as real number. So till now we had learned about the real numbers. Real numbers are having two parts. One is rational, another one is irrational. Now we'll understand what are rational and what are irrational numbers.
Closely look into this image. It shows the speedometer of a bike. Below the speedometer is a bar that shows the distance traveled. We can see that the measurement recorded is a whole number and can be read easily. However, not all measurements are recorded in whole numbers. For example, a thermometer. For every degree rise in temperature, it shows a change in its reading. Also, if you observe a fruit seller's weighing machine, there is a strict change in its reading with every item added or removed. Decimal points help us record any measurement aptly.
So here they
Let us
introduce the
proceed
decimal
to
system.
understand the concept better.
So what are decimals? How we'll find it out? Rather, if we'll divide two numbers, we may get a decimal
Fractions
in
can
the
be
answer, like
converted
5 by
into
2.
decimals by simple division. We know that 5 cannot be directly reduced by 2, hence we use decimal points.
So if we'll divide 5 by 2, you'll get 2.5. That is 2 decimal 5. The decimal part is 0.5 and 2 is integral part.
Decimal points are used to separate the whole and the fractional part of a number. When we divide fractions, 3 cases may occur. 1. When the remainder becomes 0 and has a definite quotient.
Like 5 by 2, when we divided 5 by 2, that was remainder I was having 0, remainder becomes 0, and a definite quotient in the form of fractional part. The fractional part is limited.
For example, in the fraction 4 by 10, when 4 is divided by 10, we simply get the remainder as 0 and the quotient as 0.4. These are known as terminating decimal numbers. Second, when the remainder never becomes 0 and have recurring digits in the quotient. For example, when
So in the previous case, when you divide 4 by 10, the answer becomes 0.4, and that answer is 0.4. Certainly it was a 0.4 only. But in this case, when we divide 10 by 3,
10
the
is
answer will
divided by
go
2,
beyond the
we see that
point.
the
The
digit
will not have the
1
certain limit,
repeats
certain
itself
digits
as
on the
the
answer.
remainder, and the digit 3 repeats itself as the quotient. These are known as meeting but recurring decimal numbers.
So in the previous case, the number was terminating decimal, and in this case, non-terminating but recurring decimal number. The 3 is recurs itself again and again. So this can be represented as 3.3 bar.
Third, when the remainder never becomes 0 and do not have recurring digits in the quotient. For example, when 22 is divided by 7, the quotient is 3.1428571 and so on.
So in the case when the remainder never becomes 0 and do not have the recurring digit in the quotient, then the answer will not have the same number of digits repeating itself or the same digits repeating itself. Then these cases are known as non-terminating, non-recurring. Though the example is not given the perfect way, as 22 by 7 is 3.142857, 142857, 142857. In this case also 142857 repeats itself, though it is not a number which is non-terminating, non-recurring, but for the example you can consider it as 3.1428571, which is not repeating till now. So the number which is non-terminating, non-recurring are known as irrational number.
These are known as non-terminating and non-recurring decimal numbers. Thus, we see that there are 3 types of decimal numbers, namely terminating, non-terminating but recurring, non-terminating and non-recurring.
So in 3 types of decimal, one is terminating, one is non-terminating, non-recurring, and another one case is non-terminating and non-recurring. So the terminating and non-terminating but recurring are rational, and the one which is non-terminating, non-recurring are irrational. Let's have an example.
We know that rational numbers are numbers that can be expressed as fractions in the form of A by B. Thus, if a decimal number can be changed into the form of A by B, then it is said to be a rational number. Given here are a set of decimal numbers: 0.51, 2.5, 1.8, 0.51 can be converted to its fractional form, that is 51 by 100. Similarly, 2.5 can be written as 5 by 2.
Here you can represent 2.5 as 25 by 10, and after reducing it or after simplifying it by 5, you can get 5 by 2. Same in the case of 1.8, it will be 18 by 10 or 9 by
And 1.8
5.
can be written as 9 by 5. Therefore, we see that all the given decimal numbers are rational numbers.
So here we had seen the decimals which are terminating. Now
Can all decimal number be converted into fractions? Of course not. There are many
So
such
all
decimal
the
numbers
decimals
which
cannot be able to convert into fraction in the form of p by q. There are certain numbers
For
which cannot be
example,
able to convert
the
in the form
value
of fractions,
root 2,
like root 2.
root 3, pi, and so on. The solution of square root of 2 goes is 1.4142136, and it goes on beyond that. It means it is non-terminating. Hence, it cannot be changed into a proper fraction. Similarly,
So here you can see root 2 is 1.414215136, which is non-terminating, non-recurring, or root 3 is 1.7320508, which is also non-terminating, non-recurring. So these numbers we cannot be able to convert in the form of p by q.
the solution for the square root 3 goes on beyond 1.73200508. Hence, it cannot be changed into a proper fraction. The
Same
value
with pi.
of pi is non-terminating, and hence it cannot be converted into a proper fraction.
So in case of pi, the pi is 3.14159 and so on, which is goes up to the trillion decimal places, but non-terminating and non-recurring. So this is the number which are considered in the system of irrational numbers.
Therefore, those numbers which cannot be exactly expressed as fractions in the form of a upon b are known as irrational numbers.
Though in case of pi, the pi is basically circumference upon diameter, which is in the form of rationals only. That is, circumference upon diameter is a upon b. So the pi initiated as rational number, but the value goes as irrational number. So further in classes 11th and 12th, we'll come to know that pi is neither rational nor irrational, but for the sake of class 9th point of view, we'll consider it as irrational. And the mathematician put the value of pi and e, that is another number, is considered as transcendental number, another category of numbers. So till now we'll consider pi as irrational number.
Now that we know the various types of decimal numbers, let us proceed to learn to mark them on the number line. Let us assume a number 2.5. We know that 2.5 lies between 2 and 3. So, let us zoom into the number line between the markings 2 and 3. Millions of numbers lie.
This method is known as successive magnification method. We can magnify the number in between two decimal numbers and we can get the desired number over here. Like 2.5, we had magnified 2 and 3 into the certain 10 parts. Though in between two integers there are there is infinite numbers exist there. So we can magnify each digit or each small part into the sub 10 parts.
Between 2 and 3, but to make it easy and precise, we divide the number line into 10 equal parts. Here we see numbers ranging from 2.1 to 2.9. Distinctly it is seen that 2.5 lies between 2.4 and 2.6. Mark it with a dot and make a circle around it, and we have the desired decimal point marked in the number line.
So 2.5 or 5 by 2 is represented on number line with the help of successive magnification method. In previous classes as well, you had learned about how to represent the fractions on number line or the rationals on number line. So these are the numbers. In the same way, you can represent the fractions and rationals on number line.
The decimal form of 3 by 55 will be, select the correct option and click submit.
So 3 by 55, as the prime factorization of 55 is 5 and 11. So this will be as 11 occurred in the prime factorization of denominator, and if the denominator is having any other number except 2 and 5, then it will be non-terminating but recurring. So I'll put this option. Yes, it is non-terminating but recurring. Next question.
The fractional form of 5.5 can be written as 55 by 10.
Yes,
select the correct option and click submit.
Yes, when we'll remove the decimal sign, it will be 55 by 10. Or we can simplify it further, but yes, we can return it, we can write it as 55 by 10 as well. So it is true.
What kind of a number is 5.2? Select the correct option and click submit.
5.2, when we'll remove the decimal, it will be 52 by 10 or 26 by 5. So it will be a rational number, or we can consider it as fraction as well, but we consider it as rational.
Here is a quick review of what we have learned so far.
So we had learned about fractions, decimals, terminating decimals, non-terminating non-decimals, and non-terminating but recurring decimals. So non-terminating but recurring and terminating decimals are rationals, whereas non-terminating and non-recurring decimals are irrationals. Just sum up with this what we had learned so far. In quick review, what are the rationals, what are the irrationals, what is the definition of rationals, and some properties of rational number. So in this, what we had learned so far will sum up.
Hello everyone. The topic of the day is number system, class 9, chapter 1. As we discussed about the rational number in the previous class, the rational number starts with natural numbers, which are the counting numbers. If we'll put 0 into that, this is known as whole numbers. If we'll add the negative numbers into the whole numbers, it is called integers. If we'll put the negative and positive fractions, that is the number in the form of p by q, where p and q are integers, then the group is known as rational numbers. So that all the natural numbers, whole numbers, integers and rationals, or the fractions, are known as rational numbers. So what about irrational numbers? The numbers which are not rational are irrational, which can be written in the form of p by q. So let's have a look on the rational number and irrational numbers. What is rational numbers? The rational numbers are numbers which are in the form of p by q, where p and q are integers and q is not equals to 0, are known as rational numbers. For example, if we talk about rational numbers, 5 by 8, where 5 and 8 are integers, minus 3 by 14, 7 by minus 15, minus 6 by minus 11, 5 by 1 or 5 only, or 0 by 1. Yes, 0 and 5 are rational numbers because we can put 1 as denominator to any number. So in 0 by 1, it is condition is given, q is not equals to 0, but p can be 0. So in 0 by 1 wala case, it is 0 by 1 is also a rational number. Now if we talk about irrational numbers, irrational numbers are numbers which can't be represented in the form of p by q is known as irrational numbers. The integer which cannot be represented in the form of p by q are known as irrational numbers. For example, under root 3, under root 7 by 4, 3.4324, any number which is not in the form of same numbers is repeating is known as irrational number. Now, how to identify rational numbers? First we'll talk about the properties. The closure property is not applicable here, as sum of two irrational is not always irrational. Commutative property is applicable over here. Associative property, addition is applicable but subtraction is not. Distributive property applicable over here. Additive inverse is available for irrational numbers, and multiplicative inverse is also available for irrational numbers. Now,
the closure property is nothing but the sum of two irrational will always irrational, so this is not applicable, as I can take minus 2 and minus root 2, minus root 2 and plus root 2. This, and when we'll add this, then answer will become 0, which is a non-irrational number, that is a rational number. Commutative property is applicable. Associative, distributive, we'll talk about root 2 bracket root 3 plus root 5, or root 2 bracket root 3 minus root 5. When you distribute root 2 inside the bracket, the answer will remain same. Whether we'll add root 3 and root 5, we cannot be able to, obviously we cannot be able to add two irrational numbers. So distributive property is also applicable over here. Additive inverse is available for any of the irrational number. Let's say root 3, so additive inverse of root 3 will be minus root 3. Multiplicative inverse is also available, that is, if we'll take root 3, the multiplicative inverse will be 1 upon root 3. When we'll multiply these two numbers, the answer will become 0. In case of additive inverse, when we'll add these two numbers, that is root 3 and minus root 3, the answer will become 0.
we'll talk about how to identify an irrational number. So we have two types of irrational numbers. One is in the form of under root and other in the form of decimal expansion. So if a number which is under root is a perfect square, this is not irrational number, that is a rational number. For example, under root 25, the value becomes 5, so it is a rational number. 0.36 under root 0.36, which can be represented as 0.6 only, it is also a rational number. If we talk about a number which is not a perfect square, it is an irrational number under root of not a perfect square number. For example, under root 2, under root 5, under root 17, under root 23. Here 2, 5, 17 and 23 are not a perfect square. So these numbers which are in the form of under root of non-perfect square are the irrational numbers. Now, if we talk about the decimal expansion, in the form of decimal expansion, the number can be terminating or non-terminating. If it is non-terminating, it can be recurring or non-recurring. So, the decimal expansion which is terminating and recurring are known as rational number. But if the decimal expansion is non-terminating and non-recurring, so this sort of number are known as irrational numbers.